da poca picchita va bene. Se tu la parla miezza americano, quando si fa l'amore sotto la luna, come da venen cave di I love you. Papà l'americano. Papà l'americano. Papà l'americano.
Hey guys, so I guess you just watched the really interesting or exciting part of our video. So I guess we'll move on to the educational part. So looking at the first slide here, we have the general equation, which is A equals Z plus N, and it's commonly used in nuclear chemistry, but as you can see here, it's also used in nuclear physics. So A is the number of protons and neutrons, Z is just the number of protons, and N represents the number of neutrons. You can kind of think of A as representing the nucleus of an atom, which contains both neutrons and protons, and then Z and N are just the components of the nucleus. Okay, so looking at the next slide here, this is kind of a bit of chemistry review, so for some of you maybe to throw back to sophomore year. And this is pretty much isotope notation. So, in the picture on the bottom left, you will see the letter A, which is the number of protons and neutrons in the nucleus of an atom, and then below that is the letter Z, which is just the number of protons. And in the middle is X, which represents the chemical symbol for any given element. So maybe you're wondering where did N go, which is the neutrons in the equation. So pretty much if you subtract Z from A, you'll get N, or the number of neutrons. So now on the picture on the right, it shows an example of different types of isotopes. For example, it shows here like the isotopes of lithium. And as you can see, they're the same element, but they just differ in the number of neutrons they have. So now I guess we'll start talking about different types of decay, and the first one is alpha decay. So this is pretty much where an element emits an alpha particle, and what an alpha particle basically is just it's a helium nucleus, and that contains 2 protons and 2 neutrons. Alpha decay also changes the element. So this is because the original element is losing protons. So if you lose protons, or vice versa, gain protons, you are changing the element. And so looking at the periodic table, for example, every alpha particle emitted, you would go backwards 2 elements on the periodic table. And here, the picture below gives you the general equation, X being the parent nucleus and Y being the daughter nucleus. So the next type of decay we'll be discussing is beta decay, and actually there are 2 types. One is beta plus and one is beta minus. So if it's beta minus, then it means the element emits an electron. However, if it's beta plus, then the element emits a positron. So similar to alpha decay, beta decay results in a different element, only it's not moving backwards or forwards to positions on the periodic table. It's more or less 1 because it's only changing by 1 proton. So in general, the equations for the 2 types of beta decays are given below, and there are also examples of isotopes of carbon going through beta decay, which are shown on the right. So the last decay that we'll be discussing here is gamma decay. And gamma decay occurs when the nucleus goes from an excited state, meaning it's at a higher energy level, and then jumps down to a lower energy level. Now, while it transitions from the higher energy level to a lower energy level, a gamma ray is emitted. The catch about this type of decay is that actually the element doesn't change. Shocking, right? Okay, so this next slide is actually just another equation, and I guess you can kind of just tack it on to the long list of equations that you already have learned about this year. And this one is pretty well known. It's E equals mc squared, but we have it here written as E equals delta m c squared. So E pretty much is the energy in joules, delta m is the change in mass, usually in kilograms, and c is the speed of light, which is in meters per second. And here, delta M represents the mass effect, which can be used in nuclear fusion and nuclear fission. So moving on, we're going to talk about nuclear fusion. So there are definitely many possibilities for nuclear fusion. It's pretty much taking smaller nuclei and combining them to make a new element with a bigger nucleus. So basically, the top numbers on either side of the equation should add up with each other, and same goes for the bottom. You can kind of think of it in terms of chemistry like stoichiometry, and in terms of that both sides of the equations have to be balanced. And here the mass effect, or the delta M, tells us about the energy being released. So basically, in a nutshell, you can kind of think of nuclear fusion as a building up type of reaction. And finally, last but not least, we have nuclear fission. Fission is pretty much the opposite of fusion. And again, there are tons of different ways to go about fission, and there are different ways that nuclei can break down. So, like in fusion, the top numbers on both sides of the equation should add up, and so should the bottom. Again, more stoichiometry. And here, the mass effect, again, also tells us about the energy being released. However, unlike fusion, think of fission as the breaking down reactions.